All right, I reckon it's a good time to get started. So I'll do the usual introduction. We've got Tyler here from the Omni Network team, who's very kindly walking us through the code base for everything that's in scope for the current competition. And obviously, there's a lot at stake, so I'm sure everyone will be listening very attentively. Yes, I'm looking at the comments now. A couple of notes. So the first one, if anyone has any questions, feel free to drop them in the chat throughout and I'll jump in when suitable. And then the second and final note is for anyone that can't join, we will upload this to our YouTube by the end of the day and share that in the channel in Discord as well. So that'll be able to be accessed afterwards as well. But you all are not here for my chat, so I will let Tyler take the reins now.
Cool. Thanks for the intro. Well, yeah, let's get right into it. I'm Tyler. I'm one of the co-founders of Omni, focused on the engineering side of our team. Just to introduce myself quickly, I've been working on Omni for about a year and a half now. We've launched like 3 test nets and are getting ready for mainnet. So excited to work with you all um, and hopefully find some highs and crits and get prepared for this mainnet launch coming up. Yeah, I'll just jump right into it because we've got a lot to cover. And I'm gonna share my screen quick. Okay, so I'm going live with my Chrome tabs open. I've got the protocol overview here and also the mono repo, so I'll use both of these throughout this call. And yeah, feel free to ping questions in the chat and then Aramis will raise them to me as necessary. So just to quickly cover the protocol overview document, at the bottom you should see a link to a couple resources here. Codebase walkthrough. This was made public on our Twitter last week. And this is a great overview of the codebase, pretty high level of all the different components. I'm gonna cover everything that we covered here, but speed run it because you have this resource already. So I'll try to cover everything there in like 10 minutes so we can get into more advanced topics for the rest of the time here. We also have some notes in our public documentation and then a link to test harnesses for smart contracts. So yeah, let's dive right in. I'll start with just reviewing the high level code base walkthrough that Corver did. So the main areas that we want to focus on in this review, first is the contracts directory. So this is where all of our smart contracts live. Specifically, we want to focus on the core here. This is what runs our cross-chain messaging and EVM. And so those are the 2 big features that we're launching in mainnet v1 here, cross-chain messaging and the Omni EVM. And so some smart contracts are required for both of them. In particular, we're looking at the cross-chain subdirectory. This is where our cross-chain messaging smart contracts live. So in particular, our Omni portal is deployed to every integrated chain. This is the endpoint for smart contract developers who want to send a cross-chain message. And it is also it's also used on the receiving side where cross-chain messages are submitted and executed. Then we have libraries, which is used in cross-chain messages. So we have X types, and I'll go into a couple of these later when we get into advanced stuff, just giving the high-level overview right now. X types used in cross-chain messaging, same with XBlock Merkle proof and Quorum. Pre-deploys are used for the EVM. So these are contracts that are pre-deployed to the Omni EVM and used for proxying consensus chain transactions, similar to Ethereum proof of stake. We have the dual chain architecture with our consensus chain, Halo, and execution chain, Geth. And we have some of these pre-deploys on the EVM. And then, oh, I guess we also have pre-deploys under Octane here. So slashing, staking, and upgrade, these are how we do, well, validator slashing, validator staking, and network upgrades. And finally, we have the token directory, and what is in scope for this review is just the bridge here. So we have Omni Bridge Common, Omni Bridge L1, and Omni Bridge Native. So those are the core smart contracts we are reviewing here. Outside of contracts, we then have Halo. And Halo is our consensus chain. This is the meat of the consensus protocol here. So within Halo, we do all of our cross-chain messaging. We run we run the Omni EVM, and we also do things that are required for each of those. So, for example, with cross-chain messaging, we have the attest module, which is how validators are actually watching cross-chain block or watching source blocks and then building cross-chain blocks, and then attesting to them so that they can get delivered to their destination. But as part of cross-chain messaging, every portal that we've deployed to an integrated chain needs to know the current validator set. That means every portal also effectively needs to run a light client that tracks the Omni validator set. And for that, we have the valsync and portal modules. That's probably one of the most advanced things that we'll cover. So I'm definitely going to deep dive into that later. But just a quick overview of what these modules do. Testing is actually how validators attest to cross-chain blocks, and we know that they're valid. Command is some CLI tooling. App is actually just wiring up the Cosmos SDK client. Config is pretty straightforward. It's how we set up the Geth and Halo client, or sorry, just the Geth clients. EVM slashing, EVM staking, and EVM upgrade are actually the Cosmos modules that watch those Solidity contracts that I just covered in the Octane directory. So quick overview is that there's a staking contract where validators can stake in the future. Users will be able to delegate Omni tokens, and those smart contracts will emit events. And when those events are emitted, the consensus chain will be watching those or watching for those events and trigger some logic in the consensus chain. And that logic is defined here. GenUtil is out of scope for the audit. That's just how we generate the Genesis files. Portal is important. This is how the Omni consensus chain. So the Omni consensus chain is not an EVM. It is a Cosmos SDK chain. But the portal here is how the Omni consensus chain can communicate with portals that are deployed on EVMs. So in some cases, the consensus chain Halo needs to tell portals about a new update. Like if we added a new chain and a portal needs to know that, hey, we support ZK Sync now. The second thing that we need to do is they need to send validator set updates. And so this portal acts as, it acts as a portal in the sense of like the omniportal.sol file, but for the consensus chain. Even though the consensus chain is not an EVM and we can't deploy Solidity contracts to it, this is how the consensus chain sends out messages to portals. This works very closely with the valsync module, and the valsync module wraps the Cosmos staking module and notes when there's a validator set update, and then uses portal logic here to send out an update to all destination chains to say, hey, validator set has been updated. Registry is how we track what chains are integrated. And all right, yeah, that's pretty much everything in Halo. Again, a high-level overview, and we'll dive into some details
So I think
later.
just one question that came through
Yeah.
whilst you were talking. So Question one, token folder. It's by design that Omni Gas Pump and Omni Gas Station are out of scope for the contest. The researchers say,
Uh,
it
yeah.
feels pretty important to the contract, similar to the bridge. Did you want to talk a little bit more to that?
Yeah, sure. Yeah, that's out of scope because that's actually not critical for the operation of the protocol. It's a utility that we've added on top, which will be deployed probably after mainnet. That just allows users to easily acquire Omni tokens for gas, but it's not the main way that users will acquire Omni tokens for gas. They can do that through the bridge. So this is just a utility that we built for users. If you remember, like back in the day in 2019, 2020, when Polygon was live, one of the biggest difficulties with using Polygon was actually getting Matic tokens on Polygon. We built this to solve that problem. It's not required for cross-chain protocol to operate. It's not required for the EVM to operate, but it's just a nice utility we have built for users. So it is out of scope for the audit. It's just a nice to have, not a critical function.
Awesome. And one other question. Is the Valset update in the portal Valsync done through an Omni portal system call?
Yes. So this is a great question, and what I want to dive into in kind of the more advanced um, section after I finish the high level overview. The TLDR is yes, anytime there's a validator set update, the consensus chain creates and packages up an X block as if it were a standard portal, even though it's just a consensus chain. And it goes through the same attestation process as a standard X block because we've already built this attestation protocol. So why don't we just dog food it for validator set updates? And so yes, the consensus chain will send out these updates as cross-chain messages or as X messages that get executed as a portal syscall. We indicate that through the consent Omni consensus chain ID. And so when those X messages are being submitted and executed, the receiving portal can say, okay, this came from the consensus chain. I'm going to execute it as a syscall. Good questions. Okay, I'm gonna finish off the high level overview, and then we can get into some more details. Probably around there'll probably be some more questions around Portal and ValSync, because that's a tricky part of the protocol, and definitely something that we want to have eyes on and dive further into. Okay, cool. So the remaining parts of the code base I want to cover live. Most of this is out of scope because most of it are just utilities, but the critical components of this are C chain and X chain. So C chain is consensus chain utilities. That's what C chain stands for. And then X chain are cross chain utilities. These are prefixes that we use across the repo that you'll see. So X refers to cross-chain components, C refers to consensus chain components, and then E refers to execution chain components. So X-chain is, or live X-chain here is how validators or any component, like the relayer and the monitor, can watch a source chain, like Arbitrum, Optimism, watch a source chain portal for X messages, and then builds them into X blocks. It is also a way to just kind of query what's happening on portals. So that's X chain, and then C chain is similar. It's a utility that allows any component to watch the Omni consensus chain, query what the latest attestations are, the state of X blocks, and then they can do whatever they want with it. In particular, the relayer uses the C chain heavily to say, okay, these X blocks have been attested to. I'm now going to get them and grab them and put them at their submit them on their destination chain. So that is live. Monitor is just utilities for monitoring what's happening. That is out of scope, but Octane is important. So Octane is used by Halo. This is actually just a Cosmos SDK module that implements the Omni EVM. The reason we separated it out is because actually other teams have been interested in using it, and we want to make it easy to import for other teams. And so it's actually just a separate module, but this module is imported by Halo and used to run the Omni EVM. So as you might be aware by reading the protocol overview document, the Omni chain consists of the execution layer and the consensus layer, and they communicate through the engine API, similar to Ethereum proof of stake. And that is what this Octane module does. So the Octane module lives in the consensus chain, but communicates, it implements the server side of the engine API to communicate with the execution client. And so yeah, I have some other details about it in here, and then also in the protocol overview document, we walk through how it works. And there's also a good link here to the Engine API visual guide. This was written a little while ago. I guess it was updated recently, but written for Ethereum directly, because this is what Ethereum uses as well with the beacon chain, but it applies to Omni as well. Okay, cool. That is Octane. And then Relay not in scope for the audit. That's actually just a Web 2 service. It is a permissionless service. Anybody can run it. But it is not critical. It is not a like a validator. It's not a staked role protocol. The scripts and static are just utilities that nobody really needs to worry about. But they're in there because this is a monorepo and there's lots of stuff in here. Okay, cool. So speed ran the high level overview. We're 17 minutes in. I would like to dive into some more advanced concepts now. If anybody has specific questions, you're welcome to put them in the chat, and that can direct where I go with this discussion. If not, I've got a good set of things that I want to cover, specifically areas of interest. I will just walk through the advanced topics here that we think are, critical or the most prone to errors and where we'd really like to get eyes. Because there are some, but that's all. So if you have questions, if you have specific questions, put them in the chat. Otherwise, I'll just walk through here. I'm gonna grab a sip of water quick. Okay, let's get started then, and I'll just go one by one with these. So starting with Cosmos SDK wiring. Halo uses, or Halo is a Cosmos SDK client, and specifically it's really configured and set up in this app directory, which is definitely in scope. The app directory actually adds all these different types, like standard Cosmos SDK types and modules, but also Halo specific types, and initializes them. We want to make sure that we've initialized everything correctly, because we realized, I don't know, this was a while ago, maybe 3 months ago now, we were missing like the slashing module or the slashing keeper, and had to initialize it. So I want to make sure that parameters that we've set are valid, and we've initialized everything that a Cosmos SDK client needs to initialize. Number two, going to spend a decent amount of time on this. So val sync and light clients. Okay, so the val sync module lives in Halo. What is its purpose? So in the standard Cosmos SDK staking module, there are validator set updates. So anytime a new validator registers, anytime validator deregisters, anytime a user delegates stake to a validator, there's a validator set update. Anytime power changes. So Omni, we use Halo. It is a standard Cosmos SDK client, but there's a lot more we need to do because it is a cross-chain messaging protocol. Anytime there's a validator set update, we need to propagate that validator set update to every Omni portal that we've deployed on Arbitrum, Base, Optimism, and in the future, more chains. And so that's what this valsync module does. So you go into the keeper, you'll see that in every end block, you'll actually see that the staking keeper is not run, is not initialized in Halo app config, and that is because we don't want the standard staking keeper to run by itself. We need it to run here, and we need to wrap it and run some logic after it. So every time that there is a validator set update, this staking keeper end blocker runs. We grab the updates, and if there are updates, we need to store them so that they can be attested to. Now, why do we need to attest to them? In a standard Cosmos SDK client, it's implicitly attested to because the validator submits the transaction and then the block gets processed. But unfortunately, because we're sending these validator updates to EVMs, we can't just send. We need to submit some proof that the new validator set is valid. And we could send like the entire Cosmos block and storage proof, but that's actually really complex to do in Solidity. There is a library that did that, and we did it in our previous testnet, but it's unaudited and it's a pretty massive Solidity code base. So we want to avoid doing that. So instead of doing that, we say, okay, there's been a validator set update. We need the current validator set to attest to this validator set update. So we store it, and then every validator attests to it. And when there is 2/3 quorum, it actually gets packaged up as an X block, but a consensus chain X block. So we use the same data structures as the Solidity like EVM portal, but it's constructed in Go, in Halo. And so we have this X block that contains, somebody mentioned this earlier, it's a syscall, a system call. And so this gets attested to, and then it gets delivered to every destination, every integrated chain. And how does it get delivered to every integrated chain? Well, that is how valsync integrates with, or that is where valsync integrates with the portal here. So this portal can be used by any Halo module. And so any Halo module can tell the consensus chain portal here, hey, I've got some system data that I need to send along to integrated chains, package it up into an X block, have the validators attest to it, and send it along. And that's what valsync module does. It says, hey, there's a validator set update. I know this from the staking module. I'm going to tell the consensus chain portal here to go send a message to all of the integrated chains. The registry actually does the same thing, but it's a bit simpler. It's just adding chains. So that is valsync. I will note that this will be modified in a future release. So it wraps the Cosmos SDK staking module after validator set updates currently. In the future, it will actually come before the validator set updates and only pass on those validator set updates once there's kind of a buffer period and we batch updates together. The reason we're not doing that now is because the validator set is currently permissioned. But in order to make this a permissionless validator set and enable delegations, we need to, we basically can't be sending validators updates every time somebody delegates. But for now, delegation is not possible. That's coming in a future release.
So
okay.
Just one quick question before we jump into the next section. Can you summarize the main uses of Omni? For example, one use is for cross-chain messages. What else does it do currently, or what else is planned for it in the future? You mentioned the staking as well. Is it similar to ETH network staking where they need 32 ETH minimum for staking? Or how does it work in Omni? What's the minimum amount for a validator to stake?
Yeah, definitely. So, um, okay, main use cases of Omni. So our goal at Omni is to solve the fragmentation problem that is becoming more and more prevalent with the proliferation of layer twos. In particular, we want developers and smart contract developers to be able to access users and capital from anywhere. Um, some people call this chain abstraction. That term is roughly defined, but the way we define it is we want developers to be able to deploy smart contracts to one chain, but benefit from users and capital that come from anywhere. So this mainnet v1 release is step one. It's establishing the building blocks for Omni, which are cross-chain messaging and state. So our cross-chain messaging and the Omni EVM. Where we're going in the future, though, is we want to build or we are building a solver protocol. So it's a protocol that allows users to lock up capital and have sophisticated intermediaries like market makers. Some people call these solvers now. That will actually go and execute things on users' behalf. This is coming in late Q4, early Q1, but it uses the cross-chain messaging and EVM that we're releasing in in the next month or two here. And so the end goal of the product is smart contract developer deploys their contracts to, say, Arbitrum, but they can use an Omni front-end SDK to have a front end that allows users to deposit from say Beats and Optimism. And the way that works is the user puts their money in a box on the source chain. An intermediary goes and deposits into a protocol on behalf of the user, and then uses cross-chain messaging to relay a proof that it happened back on the source chain. I know I'm covering a lot there, but that is a TLDR. We want smart contract developers to be able to accept user capital from anywhere. Regarding staking, there's a minimum, but it's not like 32 ETH. That's quite a high requirement, but Ethereum might actually be lowering that soon. For Omni, the minimum is just one Omni. However, becoming a validator is currently permissioned. In order to make it permissionless, which should happen over the next 3 to 6 months, we need to do a couple things. We need to enable delegations. We need to open the whitelist, and we need to upgrade the ValSync module that I'm talking about now, where instead of wrapping the staking module post staking updates, it needs to be like a prefix almost, where it batches updates together. If we didn't do that, then our cross-chain messaging protocol would effectively be unprofitable. So we need to make that change. Happy to answer that further if you're curious, but that's a future upgrade, so I'm not too worried about it for this audit.
And
But
one other
and
question on
yeah,
the ValSync. What's the difference between end block inside ValSync and end block inside a test/keeper/keeper? Do they always run at the end of the creation of a C block in a deterministic way, e.g. ValSync first and then the other one?
yeah, good question. So the way I look at this is every Cosmos SDK module has an end blocker, and that defines some logic that runs at the end of any consensus chain block. But I think the question is, okay, what order do they run in? Because if it's not deterministic, then that's a problem. So the way I would look at this is it's actually set in app.go. And if we look at end blockers, let's see. So I don't want to. It's either set here. Hmm. Okay. The short answer is it is deterministic and it's set in this config somewhere. It might be in dep inject. Where is it? App config. Let's see if end blockers. There we go. Okay. Here it is. It's in appconfig.go and then end blockers. And this is the order that it runs in. So the attest module, then the valsync module, then the upgrade module. So every time that there's a consensus chain block, it's every 1 to 2 seconds, the end blockers for each module runs. And you can see there's also begin blockers, and it's set up in the same way. All right, cool. I'm gonna keep moving on. We don't have any questions there. So just to continue on valsync. So note this here, but it's really important that validator set updates are propagated correctly. The validator set updates use what we call a syscall. So a syscall stands for a system call, like in systems programming. But you'll see in the contracts. So Omni Portal sys, we have these special calls or special events and function calls that can only be executed by the Omni consensus chain. So let's look at add validator set as an example. So I'm just going to go into xchain Omni Portal, then add validator set. So there are a couple things to note. This is a function on the Omni Portal that can be called by anybody, right? Well, not exactly. First requirement is that only the Omni Portal itself can call this. What the heck does that mean? Well, this can actually only be called via a dot call, right? So that is how we get the message sender to be the portal itself. It's because we're executing a system call here, and it's calling a function on itself. So actually, so when is this ads or when is this syscall thing used? Well, it's when we execute a standard X message. So this is when we execute an X message, and we check if an X message is a system call by checking the virtual portal address. So if the destination is a virtual portal address, then we know it's a syscall. Only the consensus chain can set that virtual portal address. And so if it is a system call, we execute this special logic that says it's a system call. And as you can see, we do some special logic to verify that. So making sure this logic is hardened and not exploitable is super important, because if anybody could send a system call to update the validator set, that's a huge problem. So sticking on adding a validator set, we know that only the portal itself can call this function because it does some verification. It needs to come from the consensus chain, and the message sender needs to be the consensus chain sender. I believe this is 0. We are considering updating this for just for I don't know what you call it, for sanity, I guess. But then we can execute this add validator set logic, which just appends the validator set to our list or excuse me, our mapping of validators. So that is how a syscall works. we wanted to note this as an area of interest because syscalls are they update network configuration for Omni. So they update the validator set ID, they update the portal integrated chains, and what was the other thing that we said? Oh yeah, set network. So set and supported chains. Yeah. And so yeah, if a syscall can be exploited, it's bad. Cool. Next bullet here. I've got Octane EVM engine. So Octane, actually there's a little bit of a story behind this that you might find interesting. In Omni Testnet 1, we actually used a protocol called Ethermint, or a library called Ethermint. Ethermint was an implementation of the EVM on Cosmos that it was built in like 2020, 2021, and it used pretty state-of-the-art technology or libraries from then. Unfortunately, it didn't scale in the way that we wanted it to. And you can actually check out our blog to talk about the engineering trade-offs that we had to make in order to support this. Some of the big ones were that it actually didn't separate consensus and execution. And so it required a couple things. One, you needed to fork Geth or an Ethereum execution client in order to support the EVM. And so anytime there was an update to the EVM, you need to go through the process of updating your fork and making sure all the dependencies are aligned, and then upgrading your network. And that is a huge pain. Maintaining a fork is a much bigger pain in the ass than you initially think. And it's also it slows you down because you can't just make upgrades happen immediately. And so we went back to the drawing board. There were a couple other problems like scalability, and block times were, minimum 5 seconds, 4 seconds. And so we went back to the drawing board, took some inspiration from Ethereum's proof of stake design, introducing the beacon chain, and the beacon chain separated execution and consensus. The beacon chain is the consensus side, and the execution client is the EVM. It can be Geth, Reth, or any other implementation. And they communicate through the Ethereum engine API. So we said, okay, cool. Well, there's this established API that connects an EVM to a consensus client. What if we could create a Cosmos SDK client to use a battle-tested consensus mechanism and implement the server side of the engine API, connect it to an execution client? And so we prototyped this. This was around January, February, and and it worked. And so, uh, theoretically, we could use like the beacon chain for Omni, like Ethereum's beacon chain, but the Ethereum beacon chain comes with a ton of technical debt. It's a very, very complex protocol that's designed to support hundreds of thousands or even millions of validators and full nodes. And so, we don't need that right now. We built this Cosmos SDK module, Octane, to use a very simple battle-tested consensus client or consensus mechanism, Tendermint, now comma BFT, and connect it to an EVM. And that's what Octane is. So kind of two big APIs that you need to know when working with Octane. It's one, the engine API, and two, ABCI 2.0. Funny enough, this would not have been possible pre-ABCI 2.0. This was a recent release by the Comet BFT Cosmos team, and it allows for additional programmability in your consensus logic. And so this was released in like late 2023, right around the time that we were prototyping it and experimenting with Omni's EVM. And so we ended up using it. And yeah, it wouldn't have been possible to build this in like 2021 because this didn't exist. And so, yeah, if you're looking into Octane, two things to cover: engine API, how does it work? And then ABCI 2.0 or ABCI++, the same thing. and what are the specific methods and things that we use here to actually run Octane. So that is Octane. One thing I will note is Octane allows for other Cosmos SDK modules, specifically modules in Halo, to hook in to the EVM client and read any Solidity events that are emitted during the previous block. So that logic is held in EVM messages here. And the way that it's hooked into, you can see an example in Halo EVM staking here. And so so you can see that when we deliver messages here, it just hooks into the EVM event type here and tells our consensus chain what logic to run. So if there is a create validator event, so you'll see there's an equivalent message in contracts Octane staking. So there's a create validator event that is emitted anytime a new validator registers. And we can parse that event and then deliver that event to whatever logic we need to in the consensus chain. This is how validators register. Same thing happens when there's a delegate event, etc. So this is just for the staking module, but the same mental model applies to the slashing and upgrade contracts as well. Okay, next. I guess the last thing there's, what to focus on is probably the interaction with or between the two clients, between Halo and Geth, because I'm making network calls there, and I'm going to make sure that nothing stalls, or when we're building blocks, clients can't stall or actually create invalid blocks. Cool. Okay. Moving on. A test module. This is the meat of the cross-chain logic, and it lives in Halo, a test. Core of the logic lives in keeper and voter. So the keeper is like a standard Cosmos SDK module. These are the messages that can be delivered to the consensus chain. And yeah, I mean, there's a lot to dive into here. But the main concept is that, actually, maybe it's easier to start with the voter. So the voter is actually what's attesting to source chain blocks and voting for them. And to do that, it uses what are called vote extensions. So I actually just linked to ABCI++, ABCI 2.0 for Octane, but it's also used for the Omni cross-chain messaging protocol. And so vote extensions are a way for validators to include non-deterministic data into a consensus chain block. How the heck does that happen? Like, I thought the whole point of blockchains was agreeing on data and making it deterministic. Well, with many use cases of blockchains, like oracles or cross-chain messaging, a blockchain needs to know about the state of something that's outside of its VM. And that's what vote extensions are useful for. You can check out like the Skip team that is building oracles using vote extensions. We are using it for attesting to the state of blockchains that are outside of Omni. So Arbitrum, Ethereum, Base, Optimism, these all exist outside of the Omni virtual machine. But we need to know about them in order to process and deliver cross-chain messages. So you can read a little bit about vote extensions in this ABCI 2.0 spec. I won't cover all of it because just for the sake of time. But this is where you should go to learn a little bit more about vote extensions. And so the way Omni uses vote extensions So a validator is running full nodes for integrated chains, Arbitrum, Optimism Base, and Ethereum. And when a portal is emitting X messages, the validator is watching it, using those X messages to build X blocks, and then attesting to those X blocks. And it says, okay, cool. I see that this block with a bunch of X messages was built on Arbitrum. And so I'm going to use my private key and sign that X block, and then include it as a vote extension in the next Halo block. And so every Halo block, it includes, standard consensus chain logic, but it also includes any of these vote extensions that validators sent along to be included. There is some validation logic, so you can't just submit any vote extension, because that would be a DOS vector for the chain, for Halo. But the validator can include any integrated source chain and XBlock, and attest to what they've seen. Now, if they've so actually, one really important thing to cover is, okay, what happens when there's a chain reorg? Like, what happens if Arbitrum reorgs? Well, if I'm a validator and I attested to some source chain X block, and the chain reorgs, then that's a problem. I've attested to some X block that isn't valid. Unfortunately, that can happen. Reorgs don't happen frequently, especially with centralized sequencers, but they do happen. We work on top of Ethereum as well, so we need to consider what happens there. And actually, now I'm getting into a bit of the confirmation strategies here, but this is very important for the attest module. So what we chose to do for this, we initially implemented exclusively finalized X blocks. So when a block is finalized, that means it cannot be changed. So for Arbitrum, they've submitted their transaction data to Ethereum. That transaction data was finalized as part of two consensus chain, or two Ethereum beacon chain epochs, which takes roughly 15 minutes, and it cannot be changed. And so delivering finalized cross-chain messages takes about 15 minutes. And that's good if you want, highly deterministic finality and no chance of reorg. But we received a lot of feedback from developers that, hey, actually, I don't care about complete finality. If it's like, 99% of cases, I'm happy to like comp my users if there was a reorg. And so we implemented something else we implemented this thing that we call confirmation strategies. And confirmation strategies allow developers who are sending cross-chain messages to choose whether they want their message to be finalized or latest. And you'll see some of this logic in contracts. So we have our libraries conf level. You'll see that it's just latest and finalized here. But this is used in the portal here. So when an X call is executed, the message sender needs to include confirmation level. And so what does this actually mean? Well, let's say Arbitrum is the source chain, and Arbitrum is building blocks, and they've built a block right now. That is considered the latest block. And the latest block, the sequencer has built and said, hey, this is the latest Arbitrum block, but it isn't finalized according to Ethereum consensus. In many cases, I don't think there's been a reorg in the entire history of Arbitrum. Don't hold me to that, though. Check with their team. But the point is that there can still be a reorg if an X message uses the latest confirmation level. And so what happens if there's a reorg? A cross-chain message might be reorged out of the chain. It might be duplicated, or its ordering might have changed. That could be a problem because it means our validators might be seeing different heads of the chain, different heads of Arbitrum. And one might say, hey, the Arbitrum X block looks like this. And another might say, hey, the Arbitrum X block looks like this. Well, what happens if our validators can't agree on the source Arbitrum? And this is where we have some more complex logic that is important to get eyes on. So what we do is we could very easily end up in a situation if there is a reorg where half the validators see one head of Arbitrum and half the validators see another head of Arbitrum. In which case we would not reach quorum and the cross-chain messages would not be delivered. But this is only true for the latest messages. And so if that situation arises, we still have the finalized stream where there can only be one finalized X block. And so in the case that there is a reorg and the validators don't actually agree, the finalized stream can override the latest stream. And so we have logic in the portal that just says, all right, it's basically a race between the latest stream. If a message, the latest and the finalized stream, if you're delivering an X block that is finalized, I'm going to check if one of these X messages was supposed to be delivered in latest but was never delivered, we can deliver it now because we have certainty about that X block. Okay, cool. So that is confirmation levels. That is the Halo voter and vote extensions. The last thing I'll mention, because it's relevant to vote extensions, the only way to execute transactions in the Omni consensus chain, there are only two ways to do it. The first, or excuse me, execute any logic or include any data in the Omni consensus chain. The first way is through vote extensions. So validators can include data via vote extensions. The second way is through the Omni EVM pre-deploys. Those are the only two ways for data to get into the consensus chain. We actually disable the Cosmos SDK or Comet BFT mempool. So it's not like users or validators can even submit transactions to the Cosmos SDK mempool if they want to update consensus chain state. Then they need to submit transactions through the EVM or through vote extensions. The caveat being, building blocks and attesting the blocks is done through standard Comet BFT. So that's not it's not included. Okay, moving on in the protocol overview doc, we have the Omni bridge. And the Omni bridge, so the Omni ERC20 token is deployed on Ethereum mainnet, and we want a way for users to be able to bridge tokens from Ethereum, from the Omni ERC20 on Ethereum to native gas tokens on Omni. And that's what this Omni bridge is used for. The cool thing about this is we needed some way to get data from Ethereum layer 1 to Omni. And the best way to do that is through a cross-chain messaging protocol. Fortunately, we already built the cross-chain messaging protocol. And so the Omni bridge actually just dog foods the cross-chain messaging protocol. And you'll see this in contracts, core source token bridge. This is where all of the logic lives here. And so there's 100 million tokens on Ethereum layer 1. That means there needs to be kind of an equivalent token mapping between L1 and Omni. So if a user says, hey, I've got some tokens, some Omni tokens on L1, I want tokens on Omni, we need to be able to give them to that user. And we do that by pre-funding the bridge on the Omni chain. So we say, there's a token in the bridge contract for every token on L1, and when a user bridges to Omni, those tokens can be unlocked, sent along to that user. Cool. Xsubmit. So actually, these last two I've basically covered already. Syscalls, I covered. Xsubmit, this is in the Omni portal where the relayer, which is a permissionless intermediary, can submit X blocks and have a bunch of X messages executed. Some interesting details on Xsubmit. So this is a permissionless function. Anybody can be a relayer. So we want to make sure that we do heavy validation on the X message and X block data here, and that because this is a permissionless function, people can't submit invalid X blocks or and get them included or executed. That would be bad. And then the other thing to note is, yeah, we do a bit of verification both on the X block Merkle root. It is a multi-Merkle proof, or a multi-Merkle proof. I forget what it's actually called. And then also proof per message. So that's Xsubmit. It's really important. This validation logic is rock solid. Cool. And then yeah, X block data structure, Merkle multi-proofs. We'll go with that. If an invalid X message can be delivered, that'd be really bad. That would break the security of the cross-chain messaging protocol. So if that's possible, it is critical. And then covered confirmation messages. Okay, we're 57 minutes in. I think I covered everything that I wanted to. There are some known issues down here that you're welcome to ask questions about as well. But at this point, I'm losing my voice, so we're going to wrap up and open up to any final questions. Otherwise, wish everyone good luck.
You absolutely smashed it. Thank you so much. I think we've got. Oh no, the question disappeared. I guess they deleted it. But if anyone has any final questions, speak now or forever hold your peace. But not forever. You can jump into the Discord or in Cantina, obviously.
Yeah, and we'll be on Cantina. We'll be triaging questions day over day. So you're always welcome to answer questions there. We haven't answered any yet, but we will get to it in the next 24 hours. So thank you guys all for your patience.
One final question. What is the rationale between choosing finalized and latest for confirmations? And then we will let
Yeah,
the
so
rest speak.
developers, when they are building contracts, they can choose finalized or latest. The way we recommend, yeah. So I see somebody said speed, exactly. So latest messages are typically delivered in about 5 seconds. Finalized messages take 12 to 15 minutes, depending on how quickly the rollup finalizes. The trade-off being a finalized message cannot be reorged and cannot be modified by the source chain. A latest message could be reorged out, and developers need to be willing to take on that risk of like a sequencer going rogue. What we generally recommend is we say, if you can actually set latest or finalized per message. So you might have logic in your smart contracts that say, if the value being sent here is less than 100 USDC, send it latest. If it's greater than 100 USDC, then use finalized. And I just chose 100 as an arbitrary threshold. You might do 1,000 or 10,000 even. But it's all about how much risk you're willing to take on as a developer.
Awesome. Thank you so much, Tyler. that was great. And as mentioned at the beginning, I will upload this to YouTube later today and share it in the channel. But really appreciate your time and the effort you went to.
Awesome. Yeah, absolutely. Well, thanks everyone for joining. Hope that the resources we provided are helpful, and I'm very excited to work with you all over the next couple weeks.